Next section is 1.3, solving polynomial and other equations. First thing we need to talk about is the polynomial equations and the zero factor property. Alright, the zero factor property says that if I have two quantities multiplied together and the product is zero. So think about that for a little bit. You have two unknowns here. Some value here, some value here. But I know that if I multiply them together, it has to equal 0. Well, then either this first one must equal 0, I'm going to call it A, or this one must equal 0, which I'll call B. Or maybe they both equal 0. We don't know. But we know that at least one of those factors needs to be 0 in order to have a product of 0. That is a zero factor product. And we use that a lot when we go to solve quadratics. So the first example, I need to change this. This should be 2x cubed minus 20x equals 3x squared. Well, when you see something like this type of polynomial, you want to get it equal to 0, because this product only works, or this property only works when it is equal to 0. So I'm going to subtract 3x squared. And now it's in standard form. Well, anytime you have a polynomial, you always look to factor if you're trying to solve it. And seeing that, I see that I have an x in every term, so I'm going to factor out an x. That's going to leave me with 2x squared minus 3x minus 20. Okay? Alright, now I want to see if I can factor this anymore. And you might have to do some guessing and checking. To get 2x squared, I know I'm going to have a 2x and then an x. And to get 20, I'm probably looking at 4 and 5. So I'm going to check positive 5 and a negative 4 here. Okay, so I had to move my screen up there. Now, I don't know if this is right. Whoops, sorry about that. So check your outers and your inners. And I get negative 3x, and that's what I was hoping to get, so I know I have the right factors. Okay, well then to solve for this, I know that if I multiply these three factors together, it has to be 0. So either this one needs to equal 0, this needs to equal 0, or this one needs to equal 0. So to solve for x in each of those, I set each one equal to 0. And now I can solve. This one's already done. Subtract 5 over to the other side. I get x equals negative 5 halves, or 2 and a half. And here add 4. So now these are my three answers. Okay, now we want to start working with rational equations. And there are 4 steps that we want to follow. Number 1, we want to identify and exclude any values that cause a 0 in the denominator. Number 2, you need to multiply both sides or every term by the least common multiple and simplify. 3, solve, and 4, always be sure you check your solution in the original equation. So our first example is going to be 2 over m minus 1 over m minus 1. That's going to equal 4 over m squared minus m. Okay, so looking at all the denominators, in order to find out what values to exclude, you need to make sure everything is factored. Well, the last denominator, I can pull out an m from this one right here. And that's going to be m times m minus 1. So if you see here, you know that you cannot have 0, m cannot equal 0, and we also do not want m to equal 1. So these are our excluded values. As long as we do not plug 0 in for m or 1 in for m, then we'll be okay. Now we want to find our least common multiple. And that's going to eliminate all denominators. It's kind of like finding a common denominator. It's going to be m times m minus 1. This denominator has an m, the second denominator has m minus 1, and the third denominator has both of those. So that is going to be what we want to multiply. You're going to have to multiply every denominator. And I'm going to take that times every term. And now when I multiply, your denominators are going to cancel. You have m over m, that's 1, so you're left with 2 times m minus 1. In the second term, the m minus 1's go away, and you're left with 1 times m, which is just m. Then in the third term, I'm going from the factor denominator here. The m's go away to 1, m minus 1 goes away to 1, and I'm left with just 4. And now I can solve this as if I would a linear equation. I do my distribution property. I'm going to combine my like terms and then add 2 over to the other side. So I got 6. Okay, that's an okay answer to get. As long as it wasn't 0 or 1, I'm alright. And then to check, 2 over 6 minus 1 over 5 should equal 4 over 30. 6 times 5. And you could check that in your calculator and you'll find out that it works. The next example is going to be x plus 12 over x minus 3 equals 1 plus 4x over x minus 3. Well, if you look at your denominators, I mean, x is really x over 1, 1 is 1 over 1, so the only denominator that has a variable, they're going to be the same, x minus 3 and x minus 3. So x, as long as x does not equal positive 3, we're going to be okay. I'm going to multiply every term then by my common denominator, which is x minus 3. And again, our denominators should work away. So you have just x times x minus 3. Second term, the x minus 3 simplify, and you're left with just 12. Then you take 1 times x minus 3, and you get x minus 3. And then you have 4x over x minus 3 times x minus 3, and I'm left with 4x. No denominators. Alright, let's distribute here. X squared minus 3x plus 12. And it looks like I'm going to have, whoops, not 3x, but I get 5x here. A quadratic, because I have an x squared. So when you have a quadratic, you want to get everything equal to 0. So I'm going to subtract the 5x, add a 3, and now I look to factor, if it will. Okay, the only things to give me x squared is x and x. And to get 15, well, probably 3 and 5. And you would check your outer product and your inner product. Okay, now comes the zero product property. I set each of these equal to 0, because one of them, if not both of them, must equal 0 in order to get 0 as the product here. So I have x equals 3 and x equals 5. But if you remembered from up above, we cannot have x equals 3. So that cannot be our answer. The only valid one then is x could equal 5, and that's it. Okay, now we're going to start solving radical equations and rational equations too. But the first one, this first example here, is going to be the square root of x plus 1 minus 12 equals negative 10. And we have this check here. It says make sure that you check all answers that are raised to even powers. So we'll do that at the end. But when you solve a radical equation, you want to isolate everything except the radical. So I need to bring this 12 over here. I have the square root of x plus 1, and then when I add 12 to both sides, it's going to equal 2. Now, what is the only thing that will get rid of a radical? You have to think about the inverse operation, and that will be to square everything. And what I do to one side, I need to do to the other side. So squaring a square root, those are inverses. They undo each other, and we're going to be left with x plus 1. 2 squared is 4. So this is a much simpler equation. And we get x equals 3. But because we squared both sides, you need to check. So here's my check. The square root of 3 plus 1 minus 12. We want to see, does this equal negative 10? Well, I get the square root of 4 minus 12. Square root of 4 is 2. And 2 minus 12 is indeed negative 10. So yes, it does work. It will not always work though, so make sure you check. Okay, the next one. It's going to be 3 times the quantity x plus 1 raised to the 3/4 power minus 9 equals 15. And if you remember from a few days ago, you can rewrite radicals in form of rational equations. Or radical equations with rational exponents, sorry. But our steps are still going to be the same. We still need to isolate the x here. So I want to get rid of everything away from this term first. So I'm going to add 9 to the other side. And then divide by 3. Okay, now you've got to get rid of that exponent to the 3/4 power. So to get rid of an exponent, you want to make it into an exponent of 1. Well, there's a little trick. If you raise both sides to the reciprocal of that power, remember, powers raised to powers we multiply. So this is 3/4 times 4/3. That's 12 over 12, which is 1. So now I have x plus 1 to the first power, and I can get rid of my parentheses. And then this is going to be 8 raised to the 4/3. So think back, this is really the cube root of 8, which is 2, and then raised to the 4th. So you have 2 to the 4th, which is 16. And we end up with x equaling 15. Now it's not necessarily important to check when we raise to even powers, but you should still check just to make sure it's the right answer. Okay, this next example, I want you to skip it. We'll talk about that later. Okay? Okay, application problems. We have a legal size sheet of typing paper has a length equal to 3 inches less than twice its width. If the area of the paper is 119 square inches, find the length and the width. So the first thing I do when I come across an application problem is if I can draw a picture, I want to do that. This would be my width, this is my length. Now it tells me that the length is equal to 3 inches less than twice its width. So I write that out. The length is equal to 3 inches less than twice the width. So if I take away 3 from 2 times w, that is going to be my length. Now, how do you find area? Because they tell us the area is 119 square inches. That's going to be the formula we want to use. Hopefully you remember it's length times width. So I have 119 is equal to my length, and I need to make sure that my equation only has one variable in it. So I'm going to use 2w minus 3 for my length, and then I just use w for my width. Alright, now we distribute. And you see here you have a quadratic because you have that degree of 2. So that means I want to get everything equal to 0. And then you're going to look to factor. Well, we know that to get 2w squared, we're going to use 2w and w. And if you play around with 119, you'll see that 17 times 7 is 119. So I'm going to try those first. And look, it works. So now I do my zero product property where I set each factor equal to 0. Whoops, sorry about that. And now I can solve for w. So my width is going to be 8.5 inches. Or my width could be -7 inches. Well, according to this problem, I'm dealing with width and length. Obviously, we want a positive width, so we want the 8.5 width. That means then my length is going to be 2 times 8.5 minus 3. 17 minus 3, and I get 14 inches. So my paper needs to be 8.5 inches by 14. Okay, the last example. I want you to go ahead and refer to page 99 and read through this example of how they work this one. It's going to be very similar to the one that we just did. So if we did one together, I want you to try to do one by yourself. Let me know if you have questions on it.